Mike, we're at the top of the hour, so we still have some folks joining in, but it looks like we've got, we want to be respectful of everybody's time. So good afternoon, everyone, and still good morning for those folks on the West Coast. Welcome to Duke's Smoke and Dye Testing webinar. We appreciate you taking the time out of your busy schedule to join us today. I head up marketing at the Dukes, and today I really want to thank Caitlin for all the logistics and managing everything for this webinar this morning. And I'm honored to introduce our speaker, Mike Ping. Mike is the National Technical Manager at Dukes and has over 23 years of extensive experience in the wastewater industry. He is a licensed professional engineer in North and South Carolina and graduated from Clemson University with a degree in electrical engineering. Mike's going to explore the techniques of using smoke and dye testing as a diagnostic tool to help identify critical issues within your sewer collection infrastructure. We encourage you to submit questions throughout using the Zoom Q&A. Any questions submitted there, it's only being reviewed by the moderators, so please feel free to ask any question. And throughout the session, we'll collect those, and when Mike's finished, we'll address those questions and pose those to him. Sort of confidentially, we'll just share what the questions are. If time permits, at the end, we will provide an opportunity if you also have a clarification question or additional question that comes up as a result of Mike's responses. Just raise your hand in Zoom and we'll unmute your mic. And with that, thank you again for joining us, and please join me in welcoming Mike Ping.
Mark, thank you for the kind introduction. And looks like everything's working good here. So yeah, this webinar is going to be about 30 minutes total, I think. So just the topics here, about 5 minutes each, just kind of a company introduction for anybody that's unfamiliar with Dukes. And then the heart of it, kind of the what, why, and how on smoke testing, some example results, and the importance of functional deliverables. And then we'll touch on dye testing. If you know the Duke's name, it's synonymous with chemical root control. And if you're unfamiliar with chemical root control, I'll say this, it's worth learning about. It was new to me as of maybe 4 or 5 years ago. And it's a very interesting component to kind of managing and operating a wastewater collection system. But in effect, it's injection of chemical to kill roots in the wastewater system, and Dukes is certainly the leader in that space. At Dukes, we have 4 primary monitoring services. These are all services. There's no selling of hardware, but we do flow monitoring. We've got a pump station monitoring service, a turnkey service. We've got the bottom left there, the overflow alert, and then we have micro detection, which is level only monitoring high density data for I&I, and we certainly do hundreds of those types of projects. So TV, pipe cleaning. I've got one picture here just to kind of designate and demonstrate that we do plenty of off-road CCTV. We've got a very robust data team and GIS centric team sitting behind all of this work. We do the CAR reports, condition assessment report, that takes it a step further and provides rehab recommendations and then associated cost estimates. So we do plenty of that. And then very similar to that, manhole inspections. Again, we've got a team, that field group that can handle the off-road type stuff, anything that's kind of unusual. And very similar to the deliverables on CCTV, a proper deliverable set, database, and so forth, with properly aligned asset identifiers and so forth. We do a lot of SLRAT work. And if you've never heard of this, SLRAT stands for Sewer Line Rapid Assessment Tool. It's in effect a scanning tool for a wastewater sanitary collection system. These tests take just a few minutes and determines kind of blockage and abnormalities within the wastewater system. And then just to highlight, we do kind of along with the TV, MSI or multi-sensor inspection. This is for big pipe, I would say technically it could start at 18 inches, but practically it's probably 24 and 30 and up in diameter. This technology has LiDAR, laser, sonar for aggregating and measuring the debris below the water line for potential cleaning on this like very critical infrastructure. So jumping into smoke testing, just to acknowledge that this is a recognized service that by the EPA, the Environmental Protection Agency, as part of any CMOM as it's called, capacity management operation maintenance program that any utility, every utility in the United States should have, which is in essence a written game plan and kind of SOP or standard operating procedure in managing the wastewater system. Just to make sure we don't leave anybody behind, I'm sure there's a few people here that maybe are newer to a wastewater collection system. Just the basics of a wastewater system. We have a producer of wastewater in the top left. Now, that's an old Roman bathroom of some sort. I've always thought it's an entertaining photo. It's floating around kind of the NASCO and industry. I've seen this photo pop up, but these days that's a home, that's an industry, that's a place of business of some kind that's connected to the public sanitary sewer collection system. Again, 1,000 years ago, that public system would be hand carved stones and a downward sloping channel that allows the wastewater to go away from the population. And then these days that is conveyed over to a wastewater treatment facility that biologically treats the wastewater. And then hopefully the effluent out of the wastewater treatment plant makes its way into the receiving body of water and is very clean water. Further downstream from that, probably there's a water treatment plant that's pulling water in that serves as drinking water. So kind of advancing to modern times, the public collection system would look something like this. There's the cylinder shape there that's a manhole. The green pipes, it's, again, it's a downward sloping open channel that conveys the wastewater. The point being with this is that the wastewater collection system is built and designed to convey a certain volume, a certain flow rate of water. And, the only way to change that would be to dig it up and put in a bigger pipe and so forth. It's not easily changed. The reason that I mention that is when we talk about smoke testing, you're talking about what's called inflow and infiltration, or I&I. And I&I is when rainwater makes its way into the wastewater system, right? So we've got some examples over on the left. The bottom left is a good example of infiltration where groundwater probably is just leaking through cracks and so forth. And, that'd probably be called a gusher, and water's making its way. And this stuff adds up quickly, as we'll see here in just a minute. Moving up from there, ponding water, probably somebody took the manhole cover off to drain this area. Then we have a, stormwater infrastructure in the top left, an inlet on a roadway. It's designed to collect as much rainwater or storm water as possible to get it out so the road can function. And so certainly don't want that guy into the wastewater system. And then the photo to the right of that, a good example of just inflow entering probably from that fit pictures from a pipe TV camera. Yeah, ideally, this example of a curb inlet, it's built specifically to drain rainwater, and ideally in a separated system. Now there are still in certain parts of the U.S. combined systems that are designed to collect both rainwater and wastewater together, but those are gradually going away. And for the most part, most utilities in the U.S. have a what's called a separated system, but that flow should make its way through ditches, creeks, whatever, make its way eventually to a stream of some kind. And what's not ideal is for that to be piped up directly to the sanitary sewer system. Right. So just to kind of put some numbers on this and the potential impacts that could result here, if an area that's 2 acres, right, of land surface, let's say funnel to drain, it to one of these structures here, and a 1-inch rain event happens over, let's say, a day or whatever, the result is that's 50,000 gallons in terms of volume if it all were to be conveyed. So it's not an insignificant amount. And then, like, if you think like, hey, if that 1-inch rain event happened within a few hours, the flow rate would, that translates into 0.25 MGD or million gallons per day, 250,000 gallons. And the flow rate over those few hours would equate to several thousand homes. Now we're talking about one single, defect or incorrect plumbing. So it's, these volumes are not insignificant. And the point of this is to just show that a wastewater collection system can be easily overwhelmed by inflow. Hopefully I'm not having let me back up here. Got carried away with my mouse, sorry. So getting into smoke testing. So this same diagram, what if we push smoke into this particular manhole? What would happen? All right. This is the very basics. Well, obviously, if we're introducing smoke, somewhat pressurized, it's going to make its way wherever it can go. Wherever there's an opening, it will go, right? So it would go over to the wastewater treatment plant. In this case, it's going to go upstream. It's going to go over to this street over on the left. And eventually, smoke would come out of the inlet itself. And we'll see more examples of it. But in a nutshell, that's to boil it really down on the most basic level. That's kind of what's going on with smoke testing. So getting into kind of the standard workflow on a smoke testing project, step one is to notify the public. When the public, quite often, most of the public, the water people and wastewater people on the call would know, like, the average person doesn't know where water goes, where it's coming from, et cetera. So if all of a sudden smoke starts popping up, guess who gets called? The fire department, right? So, step one is some sort of communication. It's a critical step in any smoke testing project. At Duke's, we put door hangers out. We've got a QR code that goes straight to YouTube that kind of shows and explains what's going on. We've got a name, a phone number, and then on the back we have it in Spanish, so that more people could know what's going on. And then step two is morning of. Typically, those notifications are 1, 2, 3 days in advance of testing. Step two, the notification of the emergency dispatch locally would happen the morning of. And it's just a courtesy call to let them know, hey, what's going on and where. So how smoke testing works. So here's the machine. We saw the purple little diagram before. This is an example of this is what most people have to do smoke testing. It literally sits on top of an open manhole. The field tech opens the manhole, takes the cover off, sets this machine down. It's kind of like a lawnmower type engine, and it introduces smoke and a lot of it, right? It a little bit pressurizes the system, right? And the smoke it enters the pipe. It could run out, hundreds of feet to maybe 1,000 feet in each direction. And, we see lots of different specs and so forth. Like sometimes utilities prefer to have like the adjacent manholes plugged, just to concentrate that smoke and pressurize it as much as possible. Our belief here is that maybe a little bit of overkill, and sometimes enough pressure can be developed to blow people's P traps out, right? So that's too much, right? So, but the first step is open the manhole cover, right? Set the machine down, start it up. Hopefully some smoke comes out. And then the step two is the field crew is usually in our case, and I think in most cases, it's probably a 2 or 3 person crew. So one person is getting the smoke machine running. If it's in a location such as a road where somebody needs to hang around and make sure nobody runs over it, then maybe that person does that, and the others go and they're literally looking for smoke. The smoke in this kind of diagram here, it's just to show any opening, could be through the ground, could be what we saw in the previous slides, but just looking for smoke coming out. So here's a good example. This photo here, it's a curb inlet on a street. So, probably collecting a good area and is a pretty significant source of inflow, right? Just to touch on like accuracy. So as we'll see, part of the deliverables is providing a map and to say like, hey, here are where the defects are, but how accurate is accurate enough? Quite often I see specifications where it's like it needs to be survey grade accuracy. My opinion is like there's nothing wrong with that other than like there's an additional effort to, you're looking at this defect. Do we really need to know within a centimeter where the smoke's coming out? The purpose of the location and the mapping is so that the recipient and the owner of the system can go out and address things and understand where this defect is, what it looks like. And, I think our position on that at Dukes is like that may be overkill. We're set up to accommodate that if necessary. But generally kind of a 3-foot number value is probably accurate enough, right? And hopefully this conveys that. So another example here, the smoke machine is running, introducing smoke. You can see the photo on the left there, smoke coming out. These are probably clean out caps that have been broken off. It maybe was plumbed up where the clean out cap is above the ground. The lawnmower guy comes over and knocks it all down. And after a period of time, it's just, depending on the layout of the land, right? It could be draining a lot of water, a lot of surface area, or it could be kind of on the side of the hill or up on the top and effectively, introducing very little. Here's another interesting example. This is from a photo from an area that I participated in. So obviously a higher end residential area. And the issue in this case is there was standing water, and, some people don't want to have standing water in their yard and are willing to pay somebody to do something about it. And, in this case, there were basically French drains positioned around and going straight into the sanitary system. So, good for the homeowner, not good for the utility responsible for treating the wastewater. Yeah, this is an important step. So, projects are of all different size, and this, while we're talking about smoke testing, this could be TV, this could be really anything. Any kind of data that's being collected in the field on a project. Look, if it's a small project and there's a problem area, and this lady here in this center photo, that particular utility knows like, hey, we just want to go out and smoke test one little area. Yeah, they could get away with like, pencil, paper, and a couple photos on an iPhone or whatever, and maybe that's okay. But systematic inspection has to have a proper data collection platform. All right, so it can be any kind of platform. There's several of them on the market that are common in the industry. At Dukes, we have a custom built specifically for us. But long story short, our field guys and personnel are running around with tablets so that they can see the background map. Like over on the right, they know where the sewer lines are. They know where they need to be walking. That line, look, it goes in between two houses. If they don't have that map, maybe they don't know that line is even there, right? So there's a lot of information going on, and quite often we're doing smoke testing where there may be 500 or 1,000 or 2,000 defects in a project area. So there certainly has to be some systematic data collection going on so that all that information can be aggregated properly. So moving on to deliverables, You know, I'm sure there are many people here that have been around pipe CCTV deliverables and manhole inspection deliverables. Look, in both of those cases, there's a very standardized deliverable vehicle. It's, you know, kind of established by NASCO. And in these cases, there's a database, a Microsoft database file. There are individual reports. There's some requirements that go into that. But generally speaking, when somebody is hired and they're like there's an industry standard, right? Now, when we talk about smoke testing, that's not really there that I've seen, right? So, you know, I see specs where it's, hey, just send us the photos, right? And you know, that can be problematic, right? So the end result here, and we're going to start looking at some examples of deliverables here, but for us at Dukes, you know, our goal is that the recipient can get their arms around the project deliverables, and it could be TV, manhole, anything, you know, in 20 minutes. That doesn't mean they've read every single sentence of of the entire report, but like there's some front end summary information where you know, whoever we're working for can understand, like, look, and for smoke testing, look, we've got a lot of defects that are over in this part of the map, or hey, we don't have any really bad defects, or hey, we've got a lot of minor defects, or whatever. But our goal is for the recipient to have their arms around it, kind of in a lunch meeting session for sure. And I think you'll see how that happens here. So here is an example. The left is a clip of the report where we begin with defect number 1 on a project, and it just goes up. So this is an example. It's defect 115, right? So we have a corresponding map, a proper GIS level map. These things can be built for 11 by 17 printing, or sometimes even 24 by 36, like a big roll-up map, whatever the case may be. But it's important to have a deliverable set where the utility can set everything on a conference table, gather with the colleagues there, and discuss kind of what the project results are. You can see on the map over there, we color code here at Dukes. This is what we do. Like, we rank every defect in terms of inflow potential. It's a very subjective, field-driven score. Our field guys and personnel, I keep saying guys, sorry. Our field personnel are trained up. Like the example here that we're looking at, the defect of the storm water inlet in front of this car, it's automatically a 5, right? If it's infrastructure built to drain water, then that's a 5, and it cascades down from there. So with the map, quickly see kind of what's going on here. It's clearly identified numerically, and then we have the report that goes along with it. So we have the defect ID. We've got the type of defect, the test number. So you can see it's test number 67. You obviously can make the correlation here, probably like it's a one test, one setup of the smoke machine could have 0 defects. It could generate a dozen defects, right? So, you know, we have the test number, we've got the defect ID, the type, the inflow potential, the intensity of smoke, and the address. Now, this is additional deliverable that we provide here. We've got an online web-based dynamic interactive platform. We call it Insight 360. It's all, you know, it's included, but it allows a utility to, you know, dynamically go over, click on defects, pictures get pulled up. You can see the defect breakdown. It's just a dynamic viewing platform. And then this also houses all of the printable deliverables, the report and so forth that maybe somebody would like to print, right? So generally speaking, on deliverables for smoke testing, obviously photos are a key piece of that. And the reason I have this X'd out, seen many specs where, hey, we need 2 photos of every defect. Well, as you know, look, if the project has 1,000 defects, then you have 2,000 pictures, right? And who knows what these pictures are, and it would take a lot of time to go through there and start clicking on photos to try to figure out what's going on. And this stuff happens all the time in our industry. You know, what really is needed is the photos, not by themselves, right? But some sort of system to prioritize and understand and quote, get it here within, 10 to 20 minutes, I'm saying. Volumetric estimates, wanted to touch on this. Sometimes specifications for projects are out there that say, hey, we want to know the flow rate of the inflow coming in this defect. Long story short, I don't know how all that can be calculated. It would probably require some kind of topographic mapping. It would require the intensity of the rain event, which is not evenly distributed. And for me, I think like that's a lot of time, effort, and ultimately money on the utility side to probably have a number that's not correct anyway. So what percentage of utilities have the bandwidth to study the flow rate of the defect? I don't know. I'm just kind of putting it out there for thought. In our minds here at Dukes, we kind of are rolling with like, hey, look, these are the defects that are probably pretty severe. These are the ones that probably are not. What are some potential challenges? Certainly homeowner issues are out there. There's all sorts of those things. Sensitive residences and businesses, hospital type place or a school, a lot of communication required on the front end, coordination and so forth to make that job successful. And then our house here with the yacht sitting, I mean, that was a area that we worked in, having field personnel kind of run around. I mean, this is a neighborhood with like NASCAR drivers and country music stars. Like you just can't roll up and start walking around the house, right? So just additional communication and all that can help make those projects go really well. And then of course, making sure that the defect has correct address, and that ties back into the data collection. Look, I wanted to put costs out here just in case, well, always get these questions, but I'm saying 50 cents to $1.50 per linear foot. Like that's where we've got people on this call from all over the place. It obviously would cost more in a large city as it would out in a rural area. And then different parts of the country have different, kind of cost structures. Like Southern California, it would cost more than in rural South Carolina, like where I am. Production can range from 20,000 feet. I've got this wrong. That should be per week. Sorry for that. So production is 20 to 40,000 per full work week. And again, that's kind of the center part of the bell curve. Certainly seen costs that are lower than that, and certainly have seen costs that are higher than that. Okay, switching gears to dye testing. Just a few minutes here on this, but at the end of the day, dye testing is about this. It helps to confirm that structure A or area A or place A is connected to structure or area B, right? It details out the kind of the connection location, specific location, and then it gives a feel a lot of times about how much, right? So it could be an infiltration type thing, and you can kind of get a sense of like, hey, it's really coming in, or it could be dye testing is not straightforward in every case. It could be that two pipes are connected because of a cross connection of fiber optic cable, right? An accidental, cross bore, I should say, right? It could flood in certain situations and it's barely coming over. So you kind of, that number 3 is kind of about how much. So back to our kind of chart that we've been using here, it's, simply put, if these two are connected, right, then, that's what dye testing is about. Now, this isn't how it happens in every situation, but just to kind of get it across here, I've got my little homemade drawing, but there's an application sometimes where dye is being basically dumped on the ground into a drainage ditch to see kind of where it's going and so forth. But just to kind of illustrate what's going on here, a common scenario would be a CCTV camera operator is part of the package here. So look, you've got a combination truck or vac truck, jet truck on site. You've got a full CCTV set up on site, right? And he may be driving the camera to see like exactly where is this coming in. Otherwise, you don't know. Like you could have TV from previous, and they may all look like laterals, right? Like Who knows which one it is, right? So in this case, you know, if the camera guy is there, he knows how far out his payout is, and he would know, for example, it's 157.5 feet. So they could mark that above ground, and if any digging needed to happen or planning and so forth, they would know the exact location. Another couple of just examples here. This is kind of an odd one, but just to demonstrate, it's not dye testing. From my experience, has been it's not just, hey, go dye test this area, send the crew out. There's requires some expertise and some experience in a lot of cases. Here, this one is I think it was smoke coming out of the crack in the road, right? And so dye testing happened, and you know, in this case, you can see where the red arrow goes and see it's coming straight in, right? So just a kind of an interesting example. And then touching on cost for dye testing, it's something that again, I'll only put this here to kind of give a flavor of the cost here. It could certainly be a little bit less than that, and it could certainly go way higher than this. A lot of times, dye testing involves plugging a stormwater section of pipes and completely filling it up. You know, if it's a bigger pipe, that can take a lot of time. It could take multiple truck passes and hoses to hydrants and, you know, all sorts of things. So, you know, generally, I think just kind of rough estimate, you know, when you have a vac truck crew, TV, you know, this kind of 4,500 or 5,000 per day, you know, they could maybe do on average a couple of tests per day. So just again, like this isn't to say this is what it costs for us or anybody else, but just kind of ballparking that guy. But just the flavor there and some examples. So I promised about 30 minutes, and we're knocking on the door here. I just wanted to mention quickly, and then Mark, you can take over. We're our next webinar probably in 6 weeks or so, maybe 2 months, will be on multi-sensor inspection, which is for large pipe. And then I'm leaving here the CS team. That's our Christina manages that on our side. She does an excellent job, and we'll be on top of it. So appreciate everybody listening in. Mark?
Thanks, Mike. There were some questions that were submitted, so we will go through those right now for you, Mike.
Okay.
And then also, and once again, I'll just remind everyone, and I see Travis, you have your hand raised up. As when we get through the questions that have been submitted, then we'll open it up and provide you with an opportunity to go live. So let me start off with the first one, Mike. Since laterals are connected to the main, does smoke, and this is a multi-parts question, Mike, does smoke come out of the drains inside houses? How do you deal with complaints regarding this? Is the smoke hazardous? What chemical is used to generate smoke?
Yeah, super good. Whoever asked that, I hope you're still in the go. Excellent question that I battle with putting too much content in this and making it long versus short, but no, that's a super good question. So the smoke is definitely non-toxic, 100%. We provide MSDS, and I think that's industry standard. And then as far as laterals, like certainly smoke makes its way up the lateral. And when I was talking about plugging and like developing too much pressure in a section, you know, look, a home should have P traps on everything, right? So part of our door hanger, part of the information included in there is like, hey, make sure your P traps are full. If you have a sink you never use, put some, run some water. If that P trap is open, smoke will definitely get inside the house. So this is a can be a very disruptive service, and the communication therefore is super important. Yeah, so it can come into a house, and typically it on a bigger project, it'll happen a time or two. It should bypass all that and go up the vent stack and out the roof. Did I cover all of it, Mark?
You got yeah, you
All
got
right.
it, Mike. That was a
Okay.
multi-part. Next question. Um, if everything is working as it should smoke be coming out of the roof?
Yes. I think in a new home that's properly plumbed, it should make its way to the vent and go out the roof. Yes. Not out of the gutter, out of the plumbing on the roof.
Okay, all right, thanks, Mike. And then so is no smoke a good thing?
No smoke. Yeah, well, in a residential area, smoke should be seen coming out of the roof. I guess if there's no smoke, then they have a plumbing issue, but generally speaking, no smoke as you're walking around would signify no defects. And yeah, I would say that that's having no defects would be good.
All right, Mike, here's the next one. Do you have any troubles with the copper wire on the smoker? That one, yeah.
So I think I know where that's going. So I've been in and around crews out while they're doing the running the machines, and I've been around it on that kind of in that capacity, but I didn't like come up in the industry like running it every day. But I think I know, I would say this, the smoke machines can be temperamental, and there certainly has to be some maintenance where the smoke fluid gets introduced kind of in the exhaust part of the machine. Like known our crews to struggle keeping those things running. So probably yes.
Right. Thanks, Mike. And then we've got two more, and then I think we still have some time to open it up. So I got a few more here. Is there recovery time or cycle needed after smoke or dye testing?
So on the dye testing side, that dye is also non-toxic. So quite often that stuff, when the project is ending, that stuff maybe gets dumped into the stream and the stream turns green or whatever. But there's no additional steps taken that I'm aware of. Other if there's homeowners right there, maybe they're verbally told. And then on smoke testing, no. I mean, smoke testing generally is quick. I put those numbers up, we get 1 to 2 miles in a full work day. So things are moving fast geographically. There's no opening the system up to get the smoke out kind of a thing. There's smoke test and move on. So I think the answer is no to that one.
Right. And then the last one, Mike, and then we'll open it. We still have a little bit of time, so we'll open it up for any live questions. What's an illegal connection and how do you avoid those?
Yeah, I had that in there, the illegal connection. So, really any kind of storm water and, any kind of connection, the utility is supposed to know about it, right? So there's on storm waters can be NPDES permits, right? And then the utility, I mean, it's illegal to dig the main line up and just, put your pipe in it and do whatever and put wastewater in it or any kind of water in it, a drain or whatever. So, you know, I may be overstating it a little, but I think it technically would qualify as an illegal connection if a homeowner, like the nicer home there that I had pictured, if they just have a French drain and they're like, hey, I don't want the water here, and they plumb it up to their service lateral. I mean, I think that would qualify as an illegal connection. I don't know that anybody's going to get fined or whatever over it. I don't know what the penalty would be, but that's what that particular project was about. So,
Okay, thanks, Mike. We still have a little bit of time, so we'll open it up. I know Travis Fisher, you so we've opened it up. Travis, you had a question, or at least raised your hand. If you wanna, I don't know if I think you raised your hand early, so you may not still have a question, but your mic is open if you'd like to ask Mike a question. It might have been, it was early on, so it might have been something he was having from an issue, or yeah. Travis, we'll give you a couple more minutes, but it might have been an early issue. Might have been having a technical question he wanted to ask, or he just accidentally raised his hand. So with that, no more live questions, Mike.
okay.
Want to thank you. I want to thank all of you for attending, and looking forward. Oh, wait a minute. Hold on. We've got a question from Patrick. Caitlin, if you can unmute Patrick. Patrick? Patrick, go ahead and ask your question. I'm wondering if we might be having James Jackson. I'm wondering if we might be having an issue with people being
Can you
able
hear
to
me?
go. Oh, there we go. There we go. Yes.
This is James Jackson. I just had a quick question. You started out with the chemical root control. I was wondering how long that takes and what procedure you use to seal up the holes after you do that.
Okay, I can talk a little bit about it, James. We've got a whole team of people that have been around that for like 40 years. So I'd have to defer to them for much more explanation. But like this, yeah, the chemical root control, that's so the foam gets applied in the sewer system. And I think their rate of production is a couple miles per day. The cost is low, but like in effect, what happens is that kind of shaving cream consistency attaches to the root. It kills the root. It does not kill the plant, right? And it kills it like up to the surface of the pipe, right? And it doesn't kill it instantly. And like if you go in and TV the next day, that root is still there. It generally takes about, I'm gonna say 2 months. Don't hold my feet to the fire on that if it's 2 or 3, but like a couple of months later, that root maybe still is sort of there, but just the slightest tap of a camera system, it just sloughs off, and with a higher flow, it sloughs off and go away. I know that your question about is probably if the root goes away, does it create a spot for infiltration? And I don't really know the answer to that, other than I know that is a common question that comes up with the root control guys. So and I don't believe, my understanding is that is a non-issue.
Okay.
So hopefully some of that helps.
Yep.
It's an interesting story. The root control story is an interest. I just got a text message from a colleague here. They say it naturally plugs the line. So I guess it stays there, and because it's not getting broken off, it
Yeah.
keeps the line plugged. But we've done I don't know how many million feet that we do per year or whatever. Like it's enough. I thought they said like enough to circle the earth like 4 times or something. Like
I got you. I was just wondering,
yeah.
watch so much CCTV at a certain point, you always just go in there and cut it, but it's nice to know that there's other methods that you can
Yeah,
go
like
about.
listen, again, like I kind of come into the company as kind of an SSES guy. If you have not heard of chemical root control and are doing like mechanical cutting of roots, like at bare minimum, it's worth learning about. And just
Oh,
you fire an email to Christina and somebody can reach out, because it's a very easy value proposition to make.
okay, perfect.
Yeah, these guys, the root control. They do little small areas, and there are cities that spend millions, kind of a thing, like where it's a program. So kind of everything in between.
Perfect. I appreciate it.
Yes, sir.
Thanks, James. Mike, that's it for
That it?
the live questions. So on behalf of Dukes and Mike and Caitlin, we want to thank all of you, and we'll follow up with reach out to you. And if you've got any questions, please reach out to the contacts that are established right there. And have a good, safe day and the rest of your week. Thanks, everybody.
Appreciate it.